Hello everyone, my name is Dita Raditya, and here I'm going to present to you about our research paper with the title Predicting Sneaker Resale Prices Using Machine Learning. Now we're going to the first part of our paper, which is background. So in the present day, the sneaker industry has evolved from a basic wardrobe necessity into a multi-billion-dollar industry with the value of $55 billion by the year of 2015. And the value of sneaker resale market itself has reached $2 billion, and it is predicted to increase by 200% in the next 5 years. And the growth of this market has led to more people to see this as a promising business opportunity. However, sneaker resale price is known to be very unpredictable, so that's the reason why in this study we were trying to create a prediction model for sneaker resale price using machine learning. And also in the end, we're trying to find out which model has better performance compared to other models. And we hope that this research can help sneaker resellers to gain more insight about future sneaker resale price. This is one of the extreme case in the world of sneaker reselling. So the sneaker was retailed for $65, and now you have to pay for $8,099 in order to get the shoes from a reseller. That is a groundbreaking 12,300% increase in price, with more than $8,000 profit in a pair of shoes. That's the reason why people are so into this sneaker reselling, because they can achieve a huge amount of profit in a simple way, which is selling a pair of shoes. And now we're going into the algorithm part. So there are a variety of machine learning methods that have been used on predictions, but for this research, we only focus on linear regressions and random forest. So the world of forecasting has been dominated by linear regressions methods, since they are easy to develop and implement, and these methods also known to have a simple yet strong ability to interpret. However, this method has a limitation when processing a nonlinear relationship. It also tends to be very sensitive to overfitting, outliers, and multicollinearity. Some researchers have proven that linear regressions have a high performance when applied to predict the commodity trading prices. And the title of the research paper is Modeling and Forecasting of Commodity Trading Price by Liu and Tim. Another famous method for prediction is random forest, which is a very popular algorithm with its ability to perform relatively high accuracy of prediction, along with its robustness to noise and also to outliers. It also has this ability to handle large dimension and many predictors. However, this method known to require more complex computational power and resources, and it also takes a longer time on training period. And there's a research paper that proved the high accuracy and performances of these methods as it being applied to predict the aqueous solubility. And the title of the paper is Random Forest Models to Predict the Aqueous Solubility by Palmer, David S. and Tim. Next, we're going on to the methodology part. And in methodology part, the first step that we do is data gathering. And in this part, we retrieve around 99,000 sneaker sales history data from StockX data contest, which consists of 52 different sneakers type. And to train this model, we use 8 variables from the datasets, which are the sneaker name, the style code, the retail price, the release date, the size of the shoe, the sale price, and the order date. Next, we did some data exploration by plotting sneaker resale price based on the shoe size and order date, along with the count of each resale price. We do this data exploration in order to see the spread of sneaker prices based on those selected features. And here in the first plot, we trying to plot the average sell price for each shoe size, and from the graph we can see that the data is pretty even, but there is some data that stands out compared to other data, which is the one in size 14.5, and there's also some data that considered low, which is the one with size 5.3 and size 1. And the next one here, we're plotting the average sell price for each month, and from the graph we can see that the data is relatively even, except in September, where the sales is considered higher than other month. And the last one is to plot the count of each sell price, and the graph shows that most of the shoes are sold below $500. Next, we did some feature engineering into our dataset by creating an additional variables such as sell price data from 4 last purchases, the rolling average of the last 4 observations, the intercept, and the total days. We were also adjusting the variables data type so we can properly fit the model, along with extracting the necessary date part. We found around 50 data inside our dataset that aren't compatible, such as the one with typos and null value, also the sneakers that had less than 50 cells. Since we can properly process those kind of data, we end up removing those data from our data. Now we're going into the modeling part of this paper. So in this part, we actually use similar requirements for both models. And the first thing that we do is do the correlation matrix analysis in order to find the strength of relationship between two variables. And we can see here in the matrix that there are some features that has a higher correlation value towards sell price compared to other features. Those features are the last 4 sell prices, which is sell like 1, 2, 3, and 4, also the rolling average from the last 4 observations. And later on, we're using those features with some additional features such as sneaker name, retail price, shoe brand, and shoe line as our independent variables in our training process. And next, we divide our data set into training set with 80% from the total and the test set with the rest 20%. And after that, we just start the training and testing process of this model using a linear regression algorithm. For random forest model, we applied the similar correlation matrix analysis, and we use the same dependent and independent variables, and we also divide the dataset with the same proportions as the one in linear regressions. And for the algorithm, we set the n estimator into a 1000, and we fill the max step value with 5. Then we just start the training and testing process of this model using the random forest algorithm. After the training and testing process, we can see the result of both models' performances. And here we use the R-square and the MSE as the statistical measurement. And we can see here that the R-square for both models are very similar, with the differences less than 0.01. But here we can see that the MSE of linear regressions is slightly lower than random forest, which means that linear regression has a fewer error inside the model, and so we can conclude that linear regression performs slightly better compared to random forest. But here, after further analysis, we can see that the R-square from the training process is slightly higher compared to the R-square in the testing process, which indicates the occurrence of overfitting in both of our models. And in order to fix that, we applied cross-validation techniques into both of the models with the k-value of 10. And after doing another training and testing process, we get our new result, the new R-square and MSE result for both models. And here we can see that the overfitting in random forest model is successfully fixed with cross-validation, as the R-squared now is increased and it is slightly higher than the R-square from the training process. And we can also see here that the MSE of the random forest is decreased by 30%, and this indicates that random forest performs better compared to linear regression as we applying the cross-validation into the models. And from the results, we can conclude that for this prediction model to predict the sneaker resale prices, we think that random forest has a better performance and it is more suitable to predict sneaker resale prices because it can handle outliers. So it will be more suitable for complex data as the one that we use in this case, and it also doesn't need much preprocessing, way less compared to linear regressions. And random forest just has a better overall performances in the term of R-square, also in the term of MSE score. That's why we think that random forest is more suitable for this model. And we also hope that in the future there will be some improvement added to this model. Maybe we can adding some social media API so it can really adjust the prediction result of the sneaker resale prices with the current event that happen in social media. And maybe we can also applying a larger data set with more variation in terms of sneaker brand and sneaker type. So because with those improvements, we can really create a better, bigger and improved prediction model to predict the sneaker resale prices. So that's all from me, and thank you for your all attention.